Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In the previous video, we talked about NumPy, this amazing Python module that is brimming with a lot of programming tools and functions that are just perfect for data analytics. In this video, we're going to focus on the most important property and programming object of NumPy, which is NumPy Array. NumPy Array could be thought as the data structure of NumPy. And basically, it is a list structurally designed to hold numbers. Not only just to hold them, but also to do different types of manipulation with them. So the best way we can learn about NumPy Array is to basically contrast it with lists. So if you don't know what lists are on Python, please watch my video on the data structures and the data structure list. And if you haven't watched my previous video, which we talked about what is NumPy in general, please watch that video as well before continuing to watch here. So like I said, in this video, we're going to contrast NumPy Array, which are basically lists specifically designed for numbers, and then with just Python lists. All right, let's get to it. Okay, so this is the second video in this Python data manipulation modules that I'm creating videos for. So in this video, like I said, we're looking at the difference between list and NumPy Array. So let's go ahead and import our module as NumPy. Our module NumPy as NP. This is our alias. And we're going to, whenever you see NP in this video, and to be honest, anywhere in the internet, as far as, you know, when they're like talking about Python codes, you can safely assume that they're talking about NumPy. So that's the famous alias for NumPy, so let's just keep with that. So one of the differences between NumPy Array and list is the fact that lists does not come with Python lists do not come with any functions that are there to accommodate manipulation and calculations of central tendencies for the members of the list. But NumPy Array, which are designed for just holding numbers and manipulating them, they do come with a lot of different functions that we can use for calculating mean, median, standard deviation, and so on and so forth. So let's go ahead and see this in action. So we've got a list of numbers. So this is our list. And then we make that as an array using this function np.array. Basically, it changes this list into a NumPy array. So we do that. So when we say list num, which is a Python list, so let me go ahead and, before doing this, let's say type of our list. So this is just gonna be a list, and let's do the same thing. And look at our array. This is going to be a NumPy array. So that's the difference between them. So once I say that mean, there is no such thing. It says, it doesn't have the attribute mean, but list has this mean. But this, NumPy array has this mean that can calculate the mean of these values, right? You can see that's how convenient this is. Or standard deviation, the list doesn't have it, but NumPy array has it. I mean, these are just a few of the functions that it has. It has many different types of functions that you can Google. If there is a function that are applied to numbers, chances are NumPy has it, right? So just Google it before giving up on NumPy. The second difference between them is that NumPy array allows for two-dimensional access, but list is just one single dimensional access. So for instance, we can only do slicing on single dimension on list, but not multiple dimensions. So we can do this. NumPy array allows us to do that as well. But let's have two-dimensional data. So this is our list, and this is that array. So when we do something like this, it says no, you cannot have two indexes here. List index must be integer or slice, not tuple, right? So this is a tuple we're passing and it doesn't accept it. But with array, it just accepts it, right? So that's another thing. We cannot have a slicing action on list, but we can have a slicing action on NumPy array. So this is a huge benefit as far as accessing different parts of our data. With NumPy array, we can slice our data in 2 dimensions, which is great. The third very important difference is that list does not allow for using index or Boolean masking, right? So these are our list and arrays, right? So we just created them. If we want to only access the index 0, which is this value, index 1, which is this value, and index 5, which is 3, 4, 5, which is this value, just list does not accommodate that, but NumPy arrays simply accommodates that. So this is using index to get access to more than one members of the list. Another thing is Boolean mask, which is basically a list of true or false Boolean values that has as the same number of elements as the list. List does not accept that. Python list does not accept that. You can see it gives an error, but this Boolean mask for the array can simply be applied to NumPy array, and it can be very useful for filtering data. If you haven't already become familiar with Boolean masking, please watch one of my videos regarding Boolean masking that will allow you to see how Boolean masking is fundamental in being able to filter data. So it's a very simple, useful tool for filtering data. The last and perhaps even the most powerful difference between list and NumPy is that list does not allow for broadcasting operations. So what is broadcasting operation? So let's see in an example. So for instance, when we try to sum a number with a list, it doesn't accept it. It says this is a list, this is a number. What are we trying to do? But when you try to do this operation with NumPy array, what it does, it broadcasts, right? So you have got +5. It broadcasts this operation to all of the members of this list, right? So that's what it does. So you've got this operation. So this is the operation, and you've got those numbers. So it broadcasts it to all of the elements. So that's what broadcasting is. And this is very powerful because this allows for such fast and not a lot of computational time for calculating and manipulating data. And that's one of the key benefits of NumPy arrays. So let's look at a couple of other examples. You cannot do such a thing to broadcast this logical operation. It doesn't like it, but you can broadcast this logical operation, create a Boolean mask, right? So this is a Boolean mask itself, right? So I can do something like this. I can say BM. Now use this for filtering, right? Do you remember? So now I can do the same thing and just use that for filtering my array, and that's Boolean masking. You cannot sum two lists. It does put them together when you have lists. So it just basically put one on top of the other. It is not what we wanted to do here, but here when you have arrays, it can broadcast the two, and it does a pairwise summation of these two values. All right, in this video we talked about the difference between list and NumPy arrays, and you can see NumPy arrays are way better data collections and data structures when we have numbers. Not only they allow us better access, but for calculations they're going to be way easier and faster and computationally more efficient. All right, until the next video.